Whenever there's an earthquake in the news, they always throw a number at you, right? A magnitude 5.8, a 7.1, a 9.0. And it's so easy to just hear those numbers and not really feel the incredible, almost mind-boggling power they represent. So today, we're going to crack the code. We're going to dive into the math behind the magnitude and show you the colossal story that's hiding inside those little numbers. All right, to really get this, let's just jump right in with an example. We're going to look at the New Madrid seismic zone. It's a super active area right in the heart of the US that has a history of big quakes. So here we go. This is a report for a magnitude 1.7 earthquake near Steele, Missouri. It's tiny, definitely not something that's going to cause any damage. But the number you really want to focus on here is 1.7. Our entire journey into the math of earthquakes starts with that one little number. Now, you're probably thinking, okay, 1.7, that's basically a 2.0. And look, in your day-to-day life, you'd be totally right. But when we're talking about earthquakes, thinking that way is, well, it's completely wrong. And understanding why is going to change how you hear every single earthquake report from this day forward. So here's the deal. Geologists had this massive problem on their hands. How on earth do you create one single system of measurement for vibrations that can be anything from a tiny little flutter you can't even feel all the way up to a ground-ripping event that can flatten a whole city? A simple ruler, from 1 to 100, it just wouldn't work, not even close. Because if the smallest little tremor we can detect is a 1 on that ruler, the biggest earthquakes ever recorded would be a number in the trillions. The ruler would have to be ridiculously, impossibly long. Just try to picture that, a tiny tremor. Now 10 times stronger. 100 times. Now 1,000,000 times stronger. How do you possibly fit all of that on one easy-to-read scale? You can't, not with a regular ruler. You need a special kind of ruler, one that's built to handle these gigantic jumps in power. And this is the brilliant solution they came up with. It's called a logarithmic scale. It's a mathematical trick that's just perfect for dealing with things that grow by massive amounts. It basically tames these enormous, unwieldy numbers and turns crazy multiplication into simple addition. It's pretty genius. So let's see how this whole concept actually gets built into the earthquake scales we hear about. You're about to see they pretty much share the same secret sauce. Okay, don't let all the symbols and numbers here scare you off. Seriously, what's really cool about this is the one thing both of these formulas have in common. You see it? That log 10 sitting right there in both of them? That's it. That's the logarithmic engine that makes the whole thing work. Now, the original Richter scale, which we now call local magnitude, basically just looked at the height of the biggest squiggly line on the seismograph. But the modern moment magnitude scale, that's way more advanced. It measures the total energy of the quake based on the actual physical tear in the Earth's crust, how big it was, how much it slipped. It gives you a much better picture of the quake's true power. And this is a really important thing for all of us to remember. Even when you hear news anchors say Richter scale, and you will, the number they're actually giving you is almost always the more accurate moment magnitude. The name Richter just kind of stuck, So we know these scales are logarithmic. But what does that really mean when the ground starts shaking? What's the actual real-world difference between, say, a magnitude 6 and a magnitude 7? Okay, if you remember just one thing from all of this, make it this. For every single whole number you go up on the scale, the shaking the size of the seismic waves gets 10 times bigger. But the total energy that's released, that shoots up by about 32 times. Yeah, let that sink in for a second. 32 times more energy. That is not a small step. That is a gigantic leap in destructive power. To put it visually, the jump in energy from a magnitude 6 to a magnitude 7 looks like this. The M7 isn't just 1 point higher, it's a whopping 32 times more energetic. That's the difference between a really strong quake and a truly major, devastating one. And it just keeps going. Let's take another step up. From a 7 to an 8. Well, a magnitude 8 is 32 times more energetic than the 7. And if you do the math, that means it's over 1,000 times more energetic than the magnitude 6 we started with. See how fast this thing blows up? And this is exactly why the magnitude 9.0 earthquake in Japan back in 2011 was such a catastrophic, literally planet-altering event. It wasn't just 2 points bigger than a major M7. No way. It unleashed about 1,000 times more energy. The math here is it's staggering. Okay, so understanding this math is obviously huge for just being aware. But why does it matter for your safety? Well, it's because that magnitude number, as powerful as it is, it only tells you about the energy released at the source, way down deep in the earth. It doesn't tell you the whole story of what's going to happen up here on the surface. The actual shaking and damage you might feel depends on a bunch of other things. How deep was the quake? Remember that little Missouri quake? It was 11 kilometers deep, which is another big reason nobody felt it. How far away are you? What kind of ground is underneath you? And, of course, a huge one is how well built are the buildings around you. All of that stuff is just as critical as the magnitude number itself. So the next time you hear that number on the news, you're not just going to hear a digit anymore. You'll hear the echo of that logarithmic leap. You'll understand the immense difference in power between a 6 and a 7, and you'll know that that number, it's just the very beginning of a much bigger, much more important story about our safety, our geology, and the incredible forces that are constantly shaping our planet.